Welcome everybody. Nice to see all the faces. Well, okay, little black boxes with everybody's names in them. So tonight what we're gonna cover is Kyle's gonna kick us off. He's got a little bit about 15, 20 minutes that he needs your attention for the lab coming up this weekend. Our agenda tonight, no quiz. We're gonna go over the homework and the exam questions. So if you have questions on a particular problem, now is your chance to ask. We'll go through them, we'll work through them in class so that we're all on the same page. We all get the same level playing field. We're gonna cover some expectations of exams going forward as well. And then we will be talking about the traverse, not the little GMC runabout, little SUV. We're going to start talking about parcels and closed loops, closed polygons. So this is starting to assemble and encompass all the different concepts we've gone over so far. So we'll get into that, but I'm going to turn it over to Kyle and let him kick us off.
Cool, thank you. How's it going? I'm technically at work, so I have my mask on. So I have posted lab 4 and 5, which is, so lab 4, just there's a lot of crap there as far as how to use a theodolite. A theodolite has a lot of knobs and whatnot. So there's a few videos, please watch them. But the upside is lab 5, there are almost no videos except for setting up the field book because it's using the exact same piece of equipment. And also the theodolite in many ways is very similar to the total station, which we're going to be using. So you just kind of pay attention. The other thing I have posted in lab 5 is a course feedback survey. That's just you helping me with just some real basic questions about how the labs are working out for you. And then I'll try to adjust going forward based on your feedback. You know, I'm giving you a point for just doing it. So I really appreciate the feedback, so do it. The other thing is that we have still not heard back about getting the Saturday labs approved. So plan on it happening, I would say, because it's a lot easier to plan on something happening and then it not working out than the other way around. So please sign up based on your availability for one of the dates. So yeah, sign up for one of the dates. I'll send a reminder email this evening with the link to the sign up sheet and plan on being there. Rain or shine, we will figure something out and it'll be a good time. That's pretty much it. Labs 4 and 5. The other thing is that I'll send you a Zoom link, but I also included the Zoom link inside the modules themselves. So yeah, I'll send a Zoom link as well this evening for the lab on Saturday morning. That's at 10 a.m. I have an office hour, an hour before things start. That's at 9 a.m. Please feel free to stop by, ask any questions. And then I guess the other thing is that, Sarah, you're going to be covering traverses and all that now. So I will also get the county assignment posted. Luckily, the county of Santa Cruz a few years ago had the foresight to digitize a lot of their surveying, a lot of their surveys and property information. So we can do it all online, which is really nice. So yeah, I'll get that posted in the next week or two. It's a pretty straightforward assignment. And it's kind of a a different look at things. Any questions, comments, feelings?
No, not really. I think it's cool that things are working out though, for the most part.
Cool. Yeah. Well, I think it's been going all as well as we can, and like I said, of course, feedback. There's a couple basic questions, and then there's just kind of a free response for like things that you would like to see more of, less of. You know, try and be constructive. That's it. Thanks, everyone.
Thank you.
All right, thanks, Kyle. So I will go ahead and share my screen. Hit share. All right. So just so we know what day it is, I don't know, they're all blending into one this year, especially. So class number 5 means we're about a third of the way through the semester. Monday, October 5th, voting 1 month, your civic duty. All right, agenda tonight, no quiz. Any questions in general about the way the class is, what's going on? Just checking in. So trying to keep up with everybody.
So
Wanted to let, go ahead.
Oh, sorry. I just had a quick question. So just for the reading, I went ahead and read a little bit of chapter 10 too, but it seemed like it was mainly focused on chapter 9 last week. Is that correct? Or we'll be
Correct.
focusing more on chapter 10. All
Yep. Yeah, 10 is coming up. That's the assignment for next week mostly. And then the following week as well. So we're going to get an intro to 10 next week and then dive into it in 2 weeks. So,
All right. Thank you.
sure. All right. So exam 1, we're going to go back, talk about what we covered, and any of the homework questions, anything that you're getting stuck on, anything you want to have explained, to walk through. I want to throw out there that Joanne, the department chair for engineering, her office hours are Monday through Friday. Kyle, do you remember what that was? Was it 1 to 2?
It's 1 to 2.
It's 1 to 2. Thank you, Marcine. All right, so she's available. If you catch Kelly Horner in the STEM Center, if you drop in there on the Zoom link, she's available. My hours are from 12:30 to 2:30 on Wednesdays. If you need an additional meeting to go over anything, just let me know, okay? I'll make time, we'll get together, we'll talk about whatever's going on and work through whatever the issue is. Then we're going to talk about the traverse, the concept of it, and the process for finding out the information that we need. What's missing? How do we present it? What do we need to do in order to take that next step into the surveying process? Expectations of the exam. So I'm going to start with this. 3 basic principles: fairness on both sides, preparation, and integrity. These are 3 concepts I want to kind of cover. Fairness. I promise I've got certain expectations that I am held to from you and from the education industry, that things are handled fairly, equitably, and concisely. So last week during the exam, I continued to extend time limits. For students that already turned theirs in, this wasn't fair to them. So I screwed that up, and I don't want to do that again. So we will have a time limit. We will stick to that time limit, turn it in by that point or not. That's your call, that's your responsibility. Okay. Preparation. I am expected to prepare an exam that is indicative of what we've covered. I'm not going to quiz you or give you an exam questions on something we haven't covered, something we haven't discussed, something we haven't gone over. All right, so that's my part of the preparation, is that it will be presented to you in a format. Your preparation is going to be the homeworks, the readings, attending class, or viewing the lectures in a timely manner. Okay, it's okay if you miss a class. You get to catch up because we are recording these days, posting them. You can watch them literally at any time. But if you wait until the day of to catch up on last week's recording, you're only shooting yourself in the foot. Okay, you got to keep up with it because we're going to keep moving forward. At this point in time, it's not fair for me to go back and review some of the trigonometry questions, right? Happy to talk about it, but that's the day one kind of stuff that we went over. We're compounding on top of that. So we need everybody to be prepared, everybody to be moving forward, okay? We all have to move at the same pace. Integrity. This one I also screwed up a little bit. According to Joanne, she dropped an F-bomb on me in terms of how I handled it. So the first exam, we're all new to doing exams via Zoom, remotely, independently, with unlimited resources. Nobody's watching over our shoulders. That would have been a godsend back in my day. Not going to happen, right? If you look back at all the old notes about this class, you got one 3x5 card of notes to bring into an exam. How do I monitor that? How do I control? So I'm to mention that it was open book and open note. Seems pretty fair. It doesn't mean it's open Google. It doesn't mean it's open Neighbor. The integrity portion, the academic honesty, is crucial. I need to know that you understand the concepts. That's the point behind the exam. I can also completely sympathize that starting out at Cabrillo, whether you're a freshman or a sophomore, you're still getting your feet wet. This year has been an unbelievable shit show for everybody. So I understand the desire to get a win under your belt, right? It's not done maliciously. You're just looking to answer the question. But there is an academic honesty that we're looking for that's expected. I need to know that you understand the material. That's what the exam is for, okay? I'd like to give everybody unlimited time, unlimited support, unlimited help. It's not the way this is ever gonna work, okay? I'm relying on honesty and ethical behavior from your end, as well as mine. I don't talk about anybody's grades with anybody else. Nobody else's business is open for discussion. So that's where the integrity side is going to come from on my end. If you ever have any questions, any concerns, don't hesitate to reach out. Don't hesitate to come to me, to Kyle, to Joanne, to anybody in the industry. We're here to help you get through, okay? No one wants anybody to fail. That's never the goal. But we both have to pull our weight. All right. And thanks to COVID, there's a reason they call it COVID-19, right? Does anybody have any questions about going forward, what the expectations are going to be? Okay. All right.
I had something to say real quick. For me, it'd be easier to stay up on top of how it's going if we got like some of the work back before the next things kept going, like the next step.
So
Because
with the exception of homework 3, and you just turned in homework 4, everything has been graded and returned immediately. Is there something that's missing?
Maybe I missed a couple. I didn't remember getting them for like, I thought it was like a week or 2. But
No,
and then some of the quizzes too, we didn't get back.
All the quizzes are
Yeah.
done. Jonathan, stick around after.
I just
after
thought
class.
they were a
Let's
little
listen to that.
late.
Is that- What's that?
All right. Okay.
So, all right. Yeah, come to me if you've got questions like that. Let's dig into it. Let's figure out if something's missing. If you're not getting something back, let me know. I don't know about it if you don't tell me, okay? Exam and homework. Are there any specific problems that anybody wants to go over? I see a chat. What do we have? Okay, chapter 9, question 13, angle D. Yeah, there was a problem with that one. I didn't realize that until today, and I apologize for that. So if you sketch out the diagram, and this is what I found here with item D, or with 913. All right, so 913, what is it? Let's pull that up so everybody can see. Are you seeing my blue beam? Thumbs up if you got it. Or are you still seeing the PowerPoint presentation?
We are seeing the book.
Okay. So as I scroll through really fast and try not to give everybody a seizure, let's look at number 13. The downside to having answers provided is you're double checking against that. It's really meant to be a gut check. It took me a while to figure it out when I went through it today. It wasn't until I really started graphing out the diagram that it started to make sense. And I figured it was. So there's 2 situations there. Bottom line, it is either south 89 degrees, 27 minutes, 37 seconds east, and D is not 109, 33, 44. Or this should have been a W and not an E. So it should have been a western bearing. South 89, 27, 36 west, and then you will get the correct answer. Do you want me to work through the problem, or does that clear things up for anybody?
It cleared up a few things for me. I mean, I drew them all on separate graphs, I guess. I put the points on in the middle, but just you saying that really helped me to see more of why I did that, because I was having a hard time going back and saying why I did some certain stuff. So
Gotcha. Okay.
Yeah, I just got a different answer because I went with the numbers and the letters provided in the drawing. So
Okay.
I just ignored their answer, I think.
And that's something to remember, is I don't mark you down for incorrect homework answers. It's the neatness, it's the presentation, it's how you submit your work. Can I follow it? Can I understand it? Then if you get it wrong, then we need to have a discussion. Or I need to point it out. And so most of the time that's what I'll do, is I'll leave a little comment or a little note box next to whatever the issue was. One thing I did see on a couple homeworks a while back, technology is fabulous, but here's the big caveat. The downside to having all this technology is if we become reliant on it and we don't understand the inputs, then the answers we get back might be wrong. And I saw it on a few homeworks that the angles were, the value of the angle was not in degrees. They took the cosine or sine of that angle as though it were radians, which is a different measurement system for circular dimensions, right? Now, here's something that I have learned. I love Excel. I spend a lot of time with it and I play in it a lot. Excel will always take the degree, the measurement of radians if you were taking the sine or cosine. Check your calculators as well, okay? I have an absolute old school HP that I can convert to read radians or degrees when I take the sine and cosine. But you've got to watch out, double check what you're getting so that you know what your input needs to be. Do you need to convert it to radians first? So for example, I've created a formula for some of the stuff we're going to go over tonight, and I had to take my angular measurement in degrees, convert it to radians so I could have Excel take the cosine of it or the sine. So watch out for the inputs, okay? I don't go down to the nth degree, the nth decimal place when I'm checking for correct answers. I assume that there's going to be some rounding issues. One of the things that I did see a few times was rounding a little prematurely, right? Carry out as many digits as you can until you come up with your answer. Then we'll deal with significant figures. Then we'll deal with how to round it. But, one of them, it was like the pacing questions for the homework. Okay, so some of those questions were, if I average all of these different paces, what do I get? Well, if you carry it out a few decimal points, you end up getting a very different answer than if you round it to the nearest whole pace, right? Right off the bat. So watch those kinds of factors. Those can come back and get you as well. So just watch out for that kind of thing when you're working on the homework. Anybody have anything else? All right, not to guilt trip you or anything while you're thinking of your questions, but office hours get very, very lonely. Stop in, see me. I've put several notes saying, come by during office hours, let's go over this, because you're taking a wrong turn, right? I want to get you back on the straight and narrow. I want to get you back on the path. So it's really helpful if you stop by. Let's work through the problems. Again, if you can't make it those specific hours, let me know, okay? Anybody got anything? You're just so eager to talk about traverses?
Well, I had a quick question about the exam, if it's okay to ask an exam question.
Yes, it is.
So I had a hard time with just the first question. I knew what vertical controls were, but then I combined that with sort of horizontal controls and said they were both elevation, sort of made the connection to sea level. But I was wondering, because yeah, for some reason I just forgot what a horizontal control was, basically, and that's all I need to. A horizontal control survey.
Okay, horizontal control is where am I on the flat plane?
Okay.
Okay, so it's the pacing lab. It's measuring those distances, those horizontal distances.
Right.
rather than
And
vertical.
and so what I guess happened is I overcomplicated it. I overthought what it actually was. So that makes
Yeah.
sense.
That happens.
Yeah.
We all do that.
All right. Thank you. And that really helps quite a bit.
Good. I remember there was a project manager and his manager, and the project manager had been asked a question, and this is one of those guys that just never stopped talking. And it never made any sense. And so finally, I'll use names here. Tom turns to Mike and says, Mike, I asked you what time it was, not how to build the watch. So that has stuck with me for a long time because
Yeah.
it's a great saying, but it's also, can I get this answer more quickly,
Yeah.
more concisely, more succinctly, and everybody can move on with their lives. That's just my little.
Well, that does help a lot. It's something that I need to constantly keep in mind. So thank you. That's another good saying.
Everybody has to
Bad.
keep it in mind.
Right. All right. I appreciate that.
So, anybody else? All right. Overall, what did you think of the exam? Fair? Reasonable?
Yeah, I thought it was reasonable. It was a good challenge, and some of the stuff I realized I just need to go back and work on my time management a little more. So it was good. It was introspective. I guess you could put it that way. So it just taught me what I needed to do a little more. So
Okay. Was the time sufficient? Kenny, what's up?
I could have used a little more time. I write real slow. The numbers are faster for me than the essay questions.
Okay. All right.
yeah, good point, Kenny. Yeah, just a little bit more time might have helped, but overall, I think the questions were good.
Okay.
So.
So originally, last time it was intended to be 1 hour, and I kept letting it bleed over and bleed over. So next time we'll go beyond the hour. It sounds like an hour wasn't quite enough. So we'll go longer, but we will be finite and definite about when we cut it off. Okay. So
Sounds good. Yeah.
absolutely want to be fair about all of this. So I'm learning, you're learning. Yay. Mission accomplished, right? Anything else?
I just want to know your approach for interesting shapes because I know there are shapes where they have like 5 letters and things like that. And so when doing the surveying homework, I realized that there were some interesting shapes I had to think a little bit more about. So just graph those all on separate planes and just try and visualize it like that will be the correct strategy for the most part.
You mean like taking a close up of part
Yeah,
of
a
the
close-up
structure?
view. Yeah.
Absolutely. Yeah.
All right.
Yeah, we're going to go through an example this evening, and seriously, that's what I had to do. I had a little coordinate system, little mini axes drawn with the lines coming in that I was going to analyze. So absolutely sketch it out.
Yeah.
Can't tell you how much that'll help.
Thank you.
All right. Thank you, Marcine. Perfect. Absolutely reach out, go through the student chapter. If you need more time, if it's going to be something you feel that will help you throughout the rest of your educational career, okay, not just at Cabrillo, but if time is something that you struggle with. But what I'm hearing here is that 1 hour wasn't sufficient. So let me know, communicate with me and tell me if I'm off base. Canvas, my cabrillo.edu, email address, reach out, send messages, carrier pigeons, whatever, right? Perfect. All right. Traverse. Like I said, not just the little GMC SUV. So what kind of map is this? What are we looking at? Just guess. I don't know that we've really gone into it in detail.
I think it's a parcel map with some topography on it.
Absolutely, it's a parcel map, okay? Also called a property survey. It tells us the parcel number, the address, where it is, and it gives us a lot more information, okay? So if we look at the boundaries of such a map, what do the boundaries tell us?
Boundaries tell us. Oh, go ahead. Go ahead.
Sorry. I think they're bearings.
The bearing, Enio, property lines.
Right,
What are
that's
my
what I was
limits?
gonna say.
Yeah, physically, what are my limits here, okay? And the bearings. We're used to looking at those now. They don't look like a foreign language anymore. We're starting to understand what that's telling us, okay? What else do we get?
Perimeter.
The perimeter, based on, let's see if I got that right. No, I didn't. I didn't set this up quite correctly for that answer. So there is other information that we get. Yes, the perimeter is ultimately something we can figure out. Elevations. So what are the different types of measurements we deal with within surveying? Haven't done a lot of quizzes on this. We haven't circled back a whole lot, but I will give you a hint. Well, you saw the slide real briefly, and there's 5 of them. What are 5 measurements that we use? Okay, elevations. So that's the vertical component, correct? So if there's a vertical component, what's the counterpart to that?
Horizontal distance.
Correct. So our horizontal distance,
Horizontal angle.
horizontal, you said horizontal angle?
Yes.
Perfect. Yes. Not yet on the direction. Which direction? Left to right, up and down?
I was thinking compass, but
Kenny, what was that? I didn't hear you.
I was thinking of compass headings, bearings.
The bearings, okay. So those are part of our horizontal control. Those are our horizontal angles, right? So for every horizontal component, there is a
Slope.
Yeah, vertical component. So
vertical component. All right.
right.
So we have horizontal and vertical distances. We have horizontal and vertical angles.
Angles.
What's number 5? Do you remember? Let's just say it kind of kicked everybody's ass on the quiz and the exam.
Must be corrections.
Slope.
Oh yeah, right. Right. I was like, man, what combines both vertical and horizontal? Obviously, right.
Yeah. Olga, the corrections, yes, you're right. You're right. We struggled with those. We'll probably circle back on those. This slide from the 3rd class that we had, right? Kind of went over what those horizontal and vertical components were. horizontal distances, pacing, taping, how we get those controls, how we get the vertical controls, leveling, differential leveling, working our way up a hill, the slope distance. So keep the slope distance in mind. We're going to come back to that. We're going to talk about that in a little bit. And then the horizontal angle from left to right, vertical angle up and down. That's how we define what we're looking at, okay? So on our traverse, let me get to the right slide so I know what my notes are. All right. So I kind of alluded to this. I mentioned this. Kenny, this kind of circles back to you. What does the bearing tell us?
From a starting point, which direction we're going.
Okay. Don't choke. Okay. So we found that there's two pieces of information on this, basically, right? We have our bearing and we have a distance. Kenny, this is where you were getting the perimeter. We add up all of those components. That tells us the distance between 2 points. Now here's the catch. Is it a vertical distance, a horizontal distance, or a slope distance? Okay. All right. Other information we get from this. We'll circle back. Don't keep that in mind. What are we talking about with that distance? Okay. We also get a lot of additional information off of this parcel map, this property survey. Okay. So these little plus signs that you see. So here I've got one circled, 598.4. Here's another one, 602.3, the little plus sign, and then a note, GRND, SSMH, 617.3, GARCOR. This tells us really a lot of information. Gives us an elevation, and it tells us what kind of structure is located there. SSMH, sanitary sewer manhole. Okay. GRND, it's just an abbreviation of ground. So when they took that survey and measured that point, it was on bare ground. Looking at this, kind of what I figure is that this is going to be the garage corner. Makes sense. It's a little bit smaller than this other little outline, which is probably going to be the main residential dwelling. Okay. So those are called spot elevations, right? We can't go out and run a contour line and, stay at that constant elevation. That's what measures our vertical distances, right? So we have to go out and we have to collect spots, and then we have to interpolate between them and try and figure out, okay, well, if this is point A and this is point B, if this is 5 and this is 10, then somewhere in between, that's going to be 7.5. So we kind of average it out and locate where those highlights are. What do we want to communicate? Special points like there's a manhole here. That's important. That's stuff we want to know, right? All right. So if we have a manhole that is at 598.4 and we have a ground elevation of 602.3, if I dump a bucket of water at this second point, what's going to happen to it?
It's going to go into the manhole.
Absolutely. Okay. So we zoom in here. We can see our manhole from the ground elevation down to this spot elevation on the ground, down to our manhole, the difference is about 3.9 feet, okay? Which may or may not mean anything. It all depends on how far apart those points are, right? So that's more information that we can get from this. So what if we took the corner of the garage down to the manhole and looked at what's going to happen there? What's our difference in elevation?
It looks like the whole parcel is kind of going up the hill toward the like left corner.
Uh-huh. Yep. So a little side note here, and this is just more little life tidbits. My dad was not a contractor. He was not in construction. He didn't work in this industry that I've followed into, that I've gone into. But he absolutely nailed the concept behind earthwork, okay? Behind any kind of site improvements, any kind of site construction. Surveying is the first step in that. What are we actually dealing with? What is really there? What are our elevations? What are our obstructions? Where are our points of interest? Where are the critical points that we need to know? Engineering is taking that information, and this is the phrase my dad used, gazinta gazauta. I know you're going, what the hell is she on? No, trust me. Gazinta gazauta, it's all about water, okay? We want it to drain away from our buildings. We want it to drain off of our roofs. We want good water to come into the property. We want bad water, storm drain runoff, sewage to leave the property. So it's all about how do we manage and mitigate where the water goes and where it comes from. It's all about the water that goes into the property, and it's all of the water that goes out of the property, okay? That made so much sense to me that, Olga, you're absolutely right. If we were to look at this site and we were to see that our sewer manhole was way up above our building pad, we might want to scratch our head and start asking some questions. So these kinds of maps can tell us a tremendous amount of information, right? So since these are our vertical elevations, the vertical difference between the corner of our garage and this other corner of the property, we know that this 7497, that's not going to be a vertical elevation, because we're talking about 3-digit numbers here in the hundreds of feet, but here we're only at about 75 feet. So we're saying that's going to be more of a horizontal distance. Okay. Is that, would we assume it's a horizontal or a slope measurement? We know this is going downhill. What do you think?
Station to station, so it'd be slope.
Okay. Anybody else?
I don't exactly know how the total stations work, but I would expect them to be able to measure the, you know, the horizontal distances actually, but I'm not sure.
Okay. So horizontal distance. Hang on 1 second here. All right. All right, that's our, if we have a site like this, okay, say A is our sewer manhole and B is up at our garage corner. Okay, so just kind of a backwards interpretation of that parcel map that we were looking at. What's the distance between A and B? It's fixed, right? It is what it is. A and B don't move. So if I were to take this slope distance and report that, what if I went out and graded the site and built a pad in between point A and point B? What if I was going to put a little garden shed out there? So I had to clear off a little bit of land. What if I did that?
It's going to change.
My slope is.
The distance also.
The horizontal distance between point A and point B doesn't change.
Mhm.
Therefore, what we report on two-dimensional maps is the horizontal distance between the 2 points, okay? So slope, since it can change so much over the course of a project, over the course of time, erosion, you guys are all in the Santa Cruz area, landslides are a tremendous issue. And I will say that after all the fires this season, watch out for landslides this winter when the rains, there's nothing holding the ground together now. We saw that in 1982. There was a huge drought, lots of dryness. The rains came and the mountains washed away. Okay. Yeah, I'm old. So this measurement on parcel maps are going to be horizontal distances. We don't have a really long slide deck this year or this time. So we have a bearing, which is our horizontal angle. So we know which horizontal direction to face and to head. How far we need to go to get to our other property corner. But do we know where north is?
We might have a compass.
What's that, Olga?
We probably have a compass or some other device.
All we have is this map.
Then no, we don't.
Yeah, it's not necessarily
Yeah.
clear.
Within the arrow.
Right.
We do.
Mm.
We know that that line is 83 degrees off of north.
Okay, yeah.
Okay. Yep. And Neil, thank you. Yes. Sorry, the chat window went away for me. So yeah, in the chat window, the bearings tell us which way is north. Okay. All right. Next up. So different map, different layout. We've got a problem. We're working with an engineer. We're helping him out internship in the office. Junior engineer, we just graduated. We've got a pretty straightforward traverse. Our client wants to know some more information about this parcel. We've gotten this far with our senior engineer, with our registered engineer who's guiding us and supporting us and mentoring us. But he called in sick today. And the client wants this information by the end of the day. Can we do it? We need bearings. We need distances. They want to know how big this parcel is. Am I buying 2 acres? 100 acres? Think we can figure it out?
I think I can. I'll give it a shot.
Love the attitude. Awesome. Yes. Yes. On top of this is exactly your homework. A partial traverse. Can you find the rest of the information that we need to know about it? So I would ask a lot of questions. We might not get through this whole thing in the next hours. Okay. So we're going to go through, we're going to try and break this down, try and figure out the information that we need in order to present to our owner. So we need to figure out the bearings for our lines. Looking at this, we've got distances, but we don't have bearings. We've got internal angles, except we're missing the internal angle at A. So we're going to need to figure that out as well. Determine the coordinates. So one thing that we're going to push off to next class session is the concept of northings and eastings. And really all that is a latitude and longitudinal based coordinate system. Where are we on the planet based on our coordinates? Okay. So we want to practice converting these points into those coordinates. Because when we start using global positioning system, northings and eastings are the points that they use. If you open up Google Earth, see, I think I've got it here somewhere. I'm going to take a minute to load. Let's see. Oh, isn't that pretty? All right. Let me zoom in and find where you guys are. Okay. The information that we get down here in the lower right-hand corner of the program tells us those northings and a west calculation, okay? Where am I? What are my coordinates? What's my elevation? I can pretty much define where I am. Okay. Look, it's home. So we're going to push that off. We're going to get to that next week, talk a little bit more about it, how you figure those out, what we're looking for. This week, we're just going to stick with developing coordinate systems. One of the first questions we had was, here's your line, here's the two coordinates, what's the distance between them, right? One of the things that we had to figure out. So we'll be doing that. We're going to assume that point A is going to be our 0, 0 point. I forgot what that term is mathematically. Is there a term for it? We just call it 0, 0, origin. Origin. I got it. Yay. All right. We're going to find the area in acres. I will tell you, I went through this question. I started working on it and I got to about 3.5, but I didn't even get to 4. So we're all going to go through that together tonight. The latitude and departure. So we didn't get into that. That's part of the reading that you've been assigned. But really that is the variance, the X and Y components, okay? So it all kind of comes together and figuring out the latitude and departure of these lines. We'll end up figuring those out in order to get the coordinates that we're looking for. So it will come full circle. But right now we're going to kick it off. We're going to start with computing the bearings of the remaining lines, okay? B, C, C, D, D, E, and E, A. We want to make sure we get back to closure. You guys ready? Excited? I know, you just can't contain it.
I am, because this was the question I had earlier. So thanks for going over it.
Perfect. All right, so some formulas and some little bits and pieces that are going to help us out going back and forth. And really what I need to do is combine this slide with the diagram that we're looking at on the other one. So things to remember. Handy bits of information. The sum of the interior angles of a closed polygon, indeterminate sides, right, is the number of sides minus 2 multiplied by 180. So your homework, last week we went through an example in class, right, where we figured out the interior angles of a triangle. We calculated 2 of them and then said the third one is really just 180 minus those other 2 angles, because the sum of the interior angles of a triangle equals 180. Follows that formula. 3 sides minus 2 times 180 gives us 180. One of your other homework problems, the one that Kenny asked about, where we've got that typo, same thing. 4 sides, subtract 2, 2 times 180 is 360. So you can find the 3 interior angles, subtract from 360 to find that last one, okay, find that 4th angle. Opposite interior angles are equal. So this is where I highly recommend creating a little axis system at each point. Use those extension lines. You found the deviations and the, I am totally blanking on the term, deflection angles, right? Off of one existing line, how far do I go to get to the other intersecting line? Okay, so those are the deflection angles. Finding that information and calculating what those angles are and having that little grid system, that little axis system at each point can help you determine a lot of information about the angles at that point. SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Nomenclature. So when we talk about latitude, it's how far up or down are we going. It's also our y coordinate, and it's also referred to as the northing, okay, northing. The departure is the x coordinate. It's the x component, okay? Also the easting. Even though we might be going west, it's still just referred to as the northing and the easting. Thing to remember here, so if we're looking at our quadrant system with our north, south, east, and west, north and east are both positives. South and west are both negatives. We're moving towards something, we're moving away from something. It's kind of the way to think about it, right? So anything that I'm doing over on the right-hand side of my north-south coordinate system, my compass points, anything on the right side is a positive in terms of my x coordinates. Anything on the right-hand side going west is going to be a negative, okay? Just like my x coordinate system. Same thing with north and south. North is positive, south is negative. So that's something to keep an eye on. And then there's a couple formulas that we'll get into, and it's my formula bar to get over. Same kind of thing we were looking at when we were calculating the error of closure and the precision for our differential leveling, right? For our leveling courses, when we follow a path around, okay? Calculating back our errors there. So we've done the vertical part of all this. This is really just the horizontal version of differential leveling. Okay. All right, so I'm gonna leave this up. If you want, grab a screenshot of it. It's gonna be handy and helpful to come back to. And we're also gonna need our diagram. So how do I want to do this? Because this is pretty much all I've got in terms of slides that we're going to cover. The rest will be all work. Okay, what do I want to do? Let me get out of this. Does anybody have any questions? I just love asking you guys if you have questions.
So is a plus and minus north and south, is that true in Australia also? When you go southern hemisphere, just left and right goes backwards?
No, no, north and south are still north and south. East and west is still east and west.
Kenny, you're funny. I get it.
Not toilet water.
No, no, but the sun would rise in the opposite direction that you're used to.
No, actually, it won't. Kenny, don't do this.
Well, here we're used to looking south and the sun rises on our left and sets on our right. But when we're in the southern hemisphere, we're actually looking north towards the equator. So then the sun would rise in the right and set in the left. It really messes with your head.
Okay, wait, no. Because if we are looking north, standing here in Central California or any place California, if you are facing north, looking to Canada, the sun is going to come up on your right.
Correct.
And if you are standing in Australia and you are looking north towards the equator, the sun is still going to come up on your right.
True. But when you're watching sunrises and sunset, you automatically orient yourself towards the equator no matter which way it's coming. We're going off on a tangent. I'm sorry.
Well, so it would just, if I'm facing south, all right, so let's assume you're facing the equator. You're standing in California. You look to the equator and that direction is south. Sun rises in the east. Which side is it coming up on? My right or my left? It's going to come up on my left. So if you're facing the equator, yes, north and south hemispheres, it's going to appear on a different side of your body. But that's your orientation, not planetary? I don't know if that's the right term. Does that make sense?
Yeah, I was just curious on the mapping of people in the Southern Hemisphere looked at everything the same with our Northern centric mapping system.
Yes. Yeah, it is globally accepted using a compass. Latitude and longitudinal coordinate systems. Yeah. So the equator is really an arbitrary, not arbitrary, but it really is just kind of a jumping off point, a starting point for north-south measurements. What is it called? Is it the International Dateline? No.
Null Island?
What's the, gosh. Yeah, tangent, woo, rabbit hole. So the prime meridian runs right through
Okay.
Greenwich, England, right? That's our
Yes.
0 point for longitude, right? So we have that 0 point to start measuring from. Okay. Anyway, now that Kenny
Didn't
has
mean to make you
confused the
go.
crap out of me,
Sorry, I'll go back on mute.
no, don't. It's fine. I think this is probably one of the more entertaining classes we've had. So,
Oh,
all right, you have to tell us what that was.
Wasn't me.
All right.
sorry if you heard that. That was my dog bringing me a gift.
Was it
All right,
alive?
No, it's a squeaky toy.
Okay.
All right. So you were asking if I had any questions. I was wondering when the era of closure would be necessary. In what circumstances? I mean, we've done eras of closure before, in in the previous labs, but for traverses, when would that be necessary?
All the time.
All the time?
Because if you leave that corner of the property vague, if you don't get back to your starting point, then you really got to watch and figure out what happened.
Oh, right. Yeah, I was thinking about it totally wrong. That makes perfect sense.
Okay.
Yeah.
Yeah.
All right. Thank you.
Sure. All
That's
right,
where
let
I
me get
thought
this.
that one, that's where I thought that homework problem was leading us to, is to try and do the closure thing on it.
Right.
Oh, correct. No,
Yeah.
it wasn't. It really was just a typo for them. So, because I went and looked at the 6th edition and it's not there. They completely changed the problem. So I'm pretty sure somebody already complained about it. All right, so you're seeing we've got our, so here's sidebar since we're kind of getting in and out of things. Microsoft products, pretty universal in terms of the standard office equipment that we all use. Microsoft Word, Excel, PowerPoint, you name it. One thing that I've found, and I train this when I'm going around our company and doing any kind of training, and everybody loves it. You can give yourself more real estate, more screen space by double clicking on the menu bar up top. Now, I don't know if you already know this. I don't know if I'm telling you something that you could care less about. I'm thrilled with it. If I double click it, it comes open and it stays open. Actually, it's supposed to, and it stays open. I can navigate around and see what my menus are. I can double click again and it hides it. Single click and I can access whichever part I want, go back to my document and it's gone. Works for most Microsoft products. Don't know if that'll come in handy for you, but if you kind of know where you're going, what you need, you can give yourself more room to view what's going on. Okay, so that being said, we've got our terminology, our nomenclature. We've got a rough sketch that we're going to be working on. We need to find bearings for all of our other lines. Where do we want to start? I'm going to say we want to sketch it. All right. And how do we want to do this? All right. So this is kind of rough and dirty. All right. I got a whiteboard app now. Yay. Let's see if I can get this all on one little. All right. So we can switch back if we need to. But I kind of sketched this out. Gave myself some rough dimensions. I have no idea what those horizontal measurements are. I didn't put those in. I didn't measure them out. This is not to scale. What I did was I used a ruler to kind of give myself those rough angles so I can get a feel for, am I in the right zone? Am I in the right quadrant for where I need to be for what I'm working on? So to begin, let's see. Oh, now I can't remember how to get my, where's my text? Hell. All right. Seriously, I've lost my little text thingy. All right. So this line is A to B. What do we know about A to B? We have a bearing and we have a distance. All right. Just a horizontal distance, not a slope distance. Okay. So what I like to do is I'm going to zoom in here. I'm going to get my ruler back. So hopefully you guys are following along at home, doing this on paper. I want a straight up and down, so I'm at 90 degrees. I'm going to put this right over the top of my intersection. I'm gonna do this in a different color so you can see how it stands out. Do my red pen, and I'm just gonna give myself some crosshairs. Whee! Spin that around, get back to horizontal, and I'm gonna give myself a horizontal component to this as well. Oops. There we go. All right. So the information that we've been given, our our bearing here, what is that telling us in relation to this diagram?
It's telling us the direction of the line where it's headed. So I can see how you've drawn the north in the drawing, so you can sort of see where it's going. And so based on that, you can sort of see where A and E would go based on that northeast line.
Okay. So this bearing, this is A to B, this black line that goes up to the right. Okay. So what is our northing, or not our northing, I'm already using northing and easting. Our bearing is measured off of the north meridian, right? So this angle here, oops, sorry. That angle there. What's that angle?
53.49.
Okay. Would someone do me a huge favor and convert that to a decimal? Trying to get this shrunk down here so we can have room to work. Oh, don't know how I did that.
How many decimals?
2.
0.82 or the number 53 and then 0.82.
Okay. All right. So we know that angle there. What we need to do is we need to figure out what's our next line, what's our B and C. So I'm going to copy this, label this angle B. And we'll call this point C. All right, are we having fun now? Do the same thing here. I'm going to copy this since it's already a horizontal line. And move it up to my point B. So I have my little crosshairs there. Come on. Love it when it cooperates. It does not want to go there. All right, hell, screw it. Oops. It'd be so much easier if we were in class and I had this on the board.
Yeah, I would offer to help, but I have no idea which program this is. I mean, you said it, but I haven't ever worked with it. So.
All right, so we have crosshairs here. We'll get there. Mason, would you testify that, you know, I actually got stuff done earlier? Or not, that's fine. All right, so at point B, we need to figure out what our angles are. Yeah, technology is our friend. No, I'm gonna get this. I'm sorry. I'll show you Ah, fine, we'll do it the hard way. Thank God I'm not stubborn. All right. So, actually, I didn't want to zoom in. I'm going to zoom back out. So if we look at those lines, we know this angle is 53.82. Do we know any of the other angles at B at this point?
It's the one directly across that one at the B.
Sorry, what's that?
So I don't know how to explain it. It's an angle directly across this one at the point B.
Yeah, so the alternate interior angle.
Yeah.
Right.
Bingo. Yes. All right. So my 53.82 is also right here. Is that what you're saying?
Yes.
Okay. All right. So if we know that, what do we need in order to find the bearing of this line?
We need to calculate the difference between interior angle B and that number that we just got.
Absolutely. All right. So I can't figure out how to get out of here. Ah, there we go. Woo. Yeah, if you push enough buttons, eventually it works. All right. So what we know is that this interior angle right here, the whole angle at B is 105 degrees, 15 minutes. So based on that, what is this other angle right here from B, from my south line, my south meridian over to line BC? (105.15) minus 53.82.
So
Don't
we should
forget to
convert
convert.
that 15 to 25.
Yep. So 105.25, 51.43. All right. So you get the idea. Is it 61 or 51? Well, that's the homework. Here we go. Well, that's more homework. There it is. All right.
51.
51.43. All right.
I'm sorry, when are we supposed to calculate it in decimal and when in minutes and seconds?
You can work entirely in minutes and seconds if you're comfortable with it. My personal preference is to convert to decimals, and until I actually have to report a value, I'm going to keep it in decimals. My final answer is going to match whatever data I've been given. So at this point, what we would do is go to the nearest whole minute. So we won't be reporting seconds, but my bearings should be displayed in degrees and minutes. So at this point, if we're going to record what our bearing is here for BC, then I would take that 4300ths and convert that to minutes. Does that answer your question, Olga?
Yes, thank you.
I do it this way just because it's much easier to do the decimal math than it is for me to handle the minutes and seconds.
Mhm.
So, all right. Somebody want to do that at this point, and we'll record what our line BC is. So we know we're going down and to the right. So what kind of a bearing does that give us?
South to east.
Absolutely. Yes, that's a thank you. So it's south 51 degrees. I'm going to use a D since I don't have the little degree symbol handy. All right. 26 minutes east. Pretty good. If you want me to repeat any part of this, we'll back it up. All right. For the time being, we'll keep moving forward. So now we have this angle. We have this bearing on this line. We can move on to C. So the bearing for line C to D, we're going to do the exact same thing that we've been doing. Get out our ruler. Use my little red line. I'm going to draw a vertical. I'm going to draw a horizontal if. All right. So just like the last one, what do we know about this point in space?
Right, you highlighted it before it said we know that alternate interior angle, which is
Yeah.
51.43 degrees.
All right.
And
So,
it's interesting. I've never thought to draw it out like that, to draw that little cross for some reason. What I've done instead is I've continued the line on the shape and just gone off there. So
and
that way it's a little easier.
that's what I did here as well. I just
Right.
extended my construction lines. I mean, if I were working in CAD, I miss having CAD. Oh my God. If I were working in CAD, I'd be able to draw this, get it to scale, trim the extra lengths on those lines, and all would be great, grand, and wonderful.
Mhm.
We're just sketching it in, and as you can see, they've already got the original drawing has those same kind of markings, right?
Right.
Extending the lines, inputting a quadrant, a grid system. So that's the kind of stuff that we're looking for. What am I working with? How do I figure out what I've got? Okay. So I have my 5143, but I need the bearing this line. So how am I going to come up with that? What else do I know? How did I figure it out? We have an interior angle, right?
Yeah, we add the interior angle to that 51.43, and the whole thing we subtract from 180, I think.
Correct.
Not
Olga, I'm having a hard time hearing you, but take our interior angle, 86 degrees, 56 minutes, add our 51 degrees, 26 minutes, and subtract it from 180 to find this missing angle here. Okay, so I'll use a different colored pen. So this angle here is what we're looking for our bearing, right? Oops. I'm going to say oops really a lot tonight. Just bear with me. All right. But the interior angle at C is 86. And it's almost 87 degrees, right? .93. So if we do the math on that, what does that mean this angle is? Anybody? Okay, 41 degrees, 48 minutes. Anybody else get the same answer?
I got 38 minutes.
All right.
You're
So
totally
we've
right.
got-
Yeah, it is. It is 38. Thank you.
Okay.
Yeah.
41, and then I'm, just because it's killing me here. Actually, at that point, it would probably be a 4, huh? All right. So absolutely correct. That means our bearing for this line, I don't know why it keeps putting it right there, is going to be south 41 degrees, 38 minutes west. Okay. Cruising right along. All right, so we've got 3 of our lines. Now, what I would recommend, I don't know why I say I recommend this, up to you, whatever your preference is. I'd start creating tables for stuff like this. Whether you do it by hand on scratch paper, on engineering paper, or if you have a program, a tablet that you're happy with, go for it. Like I said before, I love Excel. It does tables for you. So what I've done is I've plugged in what my known values are for this setup. Granted, I also had extra time to work on this, so I've got some stuff already pre-populated. Okay. So as we go through, getting this tabulated so that it's in an easy to follow format. So I'm not searching all over my diagram, okay? Engineering ends up getting so messy. You get papers everywhere. And I'm saying papers, but I've got at least 5 different windows open up on 2 monitors right now. I look like I live in an evil lair. But it's the life we love. Okay. So what do we do next? Okay, so we've got our angle D. We know what that interior angle is.
Right. And so we also know the other angle from C. So that'll be another alternate interior angle. So we'd subtract 82 degrees and 48 inches by that.
Okay. You guys have no idea how badly I want to zoom in and make sure I am exactly on the crosshairs, exactly on that point right there. But I'm not going to. I'm getting better.
I believe you.
All right.
Oh my goodness.
There's a certain amount of OCD that comes with engineering. Marcine, have you found that you get compulsive about certain aspects of what you're doing?
Absolutely, yeah.
Yeah. I'd say it's a sickness, but you know what? We're the ones out there creating the world, right? We're building the parts and pieces that we use to get through life on a daily basis. I think that's pretty impressive. And I'm also pretty impressed with how I got that. So, I'm easily impressed. We know what our angle is at D from our alternate interior angles, right? So that's this angle here. So I'll mark that one blue. Okay, that was almost kind of an arc. What angle are we looking for? What angle do we need to figure out the bearing?
I think we already have it. It's the north toward east, that exact angle.
Olga, I can't hardly hear you.
I'm sorry, I don't know why my connection is. We have the bearing, I think. It's north toward east of that angle, blue angle,
The blue angle,
north toward east.
that's going to be the bearing from C to D, which we just calculated.
Okay, sorry. Yeah, I'm getting lost. Sorry.
You're close. You're close, Olga. It's gonna be north to west for the bearing that we're looking for
I get lost
over there.
in those things.
So we've got this angle for this line. We need to find what's our bearing for this line here from D to E.
Right.
So our point E, let me put that point E in there. All right, so we can see that. Let me zoom. All right, does that help?
Northwest of the difference of the triangle.
Correct. All right, I'll put that one in green. Mason, did you have a question?
Well, wouldn't you just subtract 82 degrees 48 minutes by 41.64 to get D?
Very much so.
Yeah. Okay.
Did you do that yet?
No, I have not.
Well, come on.
Sorry.
Yeah, but that's exactly what I did, Mason. So I got 41 degrees and 10 minutes for that other one.
All right, so I'm gonna move this to the side a little bit because I got a bunch of lines kind of intersecting here. This one is DE, and we said it is north 41 degrees, 10 minutes west. Okay.
Right.
Get that out of the way a little bit. All right. Excellent. Cruising right along. Now, a lot of you I have not heard from. You guys doing okay? I can't look out and see blank faces and staring off into space. Okay. Luis? Viri? Victoria? Just checking. Are you asleep? Because I'm jealous. All right. Now that we've got that angle, just continue to repeat the process. This is the one, this kind of screwed me up earlier. I need you, I'm gonna need to double on this because to me, this angle is going northwest, right? That line has a bearing that's gonna go northwest. But it's so close when you look at this line here, if that's not drawn to scale, it's close enough that it might go either way. So that's where drawing these out really comes in handy, okay? Getting that sketch helps you visualize it so you know, am I in the right quadrant? Am I in the right area? Because remember what I said earlier about north and east are positive, south and west are negative. When we start talking coordinates, it's going to make a big difference whether that line is going northwest or northeast. Okay. So.
All right. And also just looking at it. So I have a question, if there's going to be any quiz questions on this. So we're going from E to A. So you might flip it up. say on a certain question, say, all right, A to E, and that'll be the opposite direction. And we'll have to be cognizant and understand that. All right.
Yes. Generally, I mean, the whole idea is not to trip anybody up with trick questions like that, right? But you're absolutely correct, and recognizing that northeast or northwest is the same as southeast, right? It's the same direction. It's whether or not I am headed that direction.
Yeah.
So
All right.
kind of coming back to what Kenny was saying earlier, if I'm standing at point A and we haven't calculated it yet, let's say I'm standing at point B and I go and I walk to point C, then my bearing is going to be south and east. But if I walk from B to A, even though the actual bearing is northeast, it's also southwest if I'm going from B to A.
Right.
Okay.
All right,
Same
thank you.
angle. But it depends on which it's hard to say. It depends on which direction you're going. It depends on which point you are, to which you are headed.
That makes more sense, because previously I was just thinking about which direction I was going, and I was like, man, that definition seems a little weird. All right.
It really does come into,
Hey, where did you get the 41 degrees, 10 west?
that was Mason's
that-
observation that we know what this interior angle is at D. It's 82 degrees, 48 minutes. And since we know what
Yeah.
this angle is from previous calculation, it was just the difference between the full angle and the partial angle.
Oh, so you just cut it in half? What are you doing?
It's not in half,
Oh.
but it's close, right? So, whoops. See, there's that oops again. All right. Let me run out the math for you here. All right. What is D? The interior angle at D. 82 degrees, 48 minutes. Right? Jonathan?
Yeah.
Okay. So my alternate interior angles from before, kind of hard to see here, but I had 41 degrees up here, 41.634, hiding behind my little smiling face.
Yeah.
Okay. So my alternate interior
Yeah.
angles are equal. I'm going to copy that and paste it down here. Oops, not there.
Okay, I got you.
All right, so that's going to go right there. Yeah. Or not. Maybe it isn't. I don't know. I haven't figured this shit out yet. All right. So we know that that full angle is 82 degrees.
Yeah.
D minus my bearing from C is going to give us another 41 degrees, 10 minutes instead of 38 minutes. So
what did you
oldest-
subtract the 82.48 from 41.64 or whatever?
yes,
Okay.
82 degrees, 48 minutes. If I subtract
Okay.
38 minutes from it, I get 10 minutes. And if I subtract 41 degrees from the 82, I get 41. So that's where the 41.
Okay, gotcha.
Cool. All right. Let's get rid of that. Similarly, now we're looking at D or E towards A. So what would the bearing of that line be?
Okay. So that's 4164.
Okay. So what angle do we ultimately want to find in order to calculate or to determine the bearing, right? From our north meridian back to the west to that first black line. That's the one we're going for there. Okay, that's the line we want to find.
Okay.
All right. This green angle here, this is where things got a little bit confusing for me. Okay. So I had to draw this one out separately. Most of these I was able to kind of navigate my way around and figure them out. This one got its own little diagram. There's 3 lines going on in here, right? But we need almost all of them in order to figure out what we're doing. The 2 red lines form a 90-degree angle. Which line is which? This is where it gets a little confusing. So the line between my north-south and this extension is going to be the same as that blue line. So I'm going to mark that with a blue as well. Okay. But what we've been doing so far with all of our other angles is determining what the alternate interior angle is. We've been using that to help us figure out what we're looking at, right? So this black line here, the angle it makes with this red vertical with my north meridian, this angle here, I'm going to copy that and see if it'll let me paste it, because it's going to be right there. That whole angle. Is that clear to everybody? Okay. All right. So since this blue angle is the one we want, that's what we need in order to figure out what that bearing is for that line. How are we going to come up with that number? What else do we know about this point? Got an interior angle. So my angle, let's see. Let's do this one in red. Between this line here and this line here, $159, what's 31.5 something, right? 0.52. Put that down a little bit so we can see better. There we go. All right, so between all those angles that we know and the ones that we're trying to find, can we do it? Do we have enough information yet?
There's one more piece of pie there, literally.
This one?
We know that, well, we know that the 159, if we continue that on, it's 180. So we just take 180 minus 159 and get that last little slice of pie there.
So we get this piece, but what does that get us? What do we do with that information?
Then we subtract that little piece from the green angle and that's how we get our blue angle.
Absolutely. Let's go purple, yellow. Let's go yellow. All right. So this angle here, Kenny, is the one you're talking about. And that
Yes.
angle is going to be the same here.
Mm-hmm.
So 180.
So if we,
Yeah.
so if we know the green, we know the yellow, we can subtract the yellow from the green to get blue.
Yep.
Actually, that's grammatically correct. Sorry, long day.
Artistically correct. We got to say it's artistically correct because we're talking primary colors here. Yellow
Yes.
and blue make green, like a Ziploc closure. Okay. So, anybody done the math yet?
Might be north 20 degrees, 41 minutes west.
Yep.
All right.
Oops. That is just my default little noise, isn't it? Oops. All right. So EA is north, you said 20, and then 48.
41.
41? Okay. All right. That's my preferred method for going around the traverse. Do my little coordinate system at each point so I can figure out my angles. Just zoom in, blow up that corner so we can see what's going on. We can get a little more detail in what we need to look at. Okay. So any questions so far?
Could I see that table real quick that you were using to put in all the data?
The one I was just tweaking? Yeah.
Yeah, this one. Oh, sorry.
Okay. Does that make sense?
So I got a different answer for EA, and I'm wondering why. Instead of 20 degrees and 41 seconds, I got 20 degrees and 29. Because what I decided to do was I decided to subtract the 41 degrees and 10, oh, sorry, not seconds, but minutes, minus the 20 degrees and 41 minutes in order to get the blue instead of the yellow on the inside.
Okay, hang on. Let's back up. Let me zoom in. We'll look at that. All right. Go ahead. Begin at the beginning.
Okay. So I did the 159 degrees and 31 minutes plus 41 degrees and 10 minutes to get that whole space right there. And then I subtracted by 180 degrees to get the yellow. And so I understand how we got the 20 degrees and 41 seconds. But then what I did was I took the green angle, the 41 degrees and 10 minutes, and subtracted that by the 20 degrees and 41 minutes, the yellow line, in order to get the blue angle, which I thought we were focusing on.
Okay, so back up to this point. You took your 159 and added the green line, the green
Yeah.
angle? Okay, so what that gives you is, for this red line, that's 180 plus the blue line. So what you can do then, I think you just took a couple extra steps. You got carried
Yeah.
away adding.
Uh-huh,
So
right.
if you take 159.52, take our red angle plus the green angle, that is also equal to the blue angle plus 180. So now you can solve for the blue angle because
Right.
we know the green, we know the red, and that'll give us the blue.
Got it. Okay. Yeah.
Okay. Did
Thank you.
that work out and give you the 20 degrees, 41 minutes?
Yeah, it did.
Okay. All right. So the next question that came up for us was, what's the interior angle at A? How do we want to go about finding that?
Couldn't you just add up the I just did it 20.68 plus 53.82 and then just subtract that from 180?
Let me get back to that. So you said the 20.68
Mm-hmm.
and which one?
53.82.
Uh-huh.
And
And
then
then
just
subtract it
do
from
180 minus that.
What do you get?
Let me do that. $105.5.
All right. So Mason's saying that this angle A is 105. What did you say, 55?
105.5.
Okay. It's 105.5. How do we double check that?
Just add them all up.
And what would be our goal? What are we
Three
expecting?
times 180.
Okay.
540.
Okay, so 540 is what we're looking for. So we want to add up all those angles and make sure that we've got the right numbers, right? Again, this is where my handy dandy friendly spreadsheet might come in handy. All right. So 53, I'm just going to do whole degrees in one column. Oops, no, that's not what I want to do. Sorry. We've got the interior angles, right? Just going to grab a random column. 105 degrees, 15 minutes. 86 degrees, 56 minutes. 82 degrees, 48 minutes. That's weird. All right, we had 159 and 31. And this is what happens when you change the font color. And you had a whole bunch of stuff hidden. Hope I didn't need that for something. Whoops. Okay. Actually, I did. Damn it. Sorry, I'm gonna back up here. Go over here now. 105, 15. Technology's great, isn't it? 86 and 56. 82 and 48. And somebody has probably already done this. 31. And then 105, and you said 0.5, so that's what, 30? Okay. And our target is 540. So what I'm going to do is I'm going to add up all the minutes first. Gotta love auto sum. 180 minutes. What does that convert to in degrees? Well, hell. Take that, divide by 60. 3 degrees. Now what I'm going to do is I'm going to add up all my full components for degrees. Then I want to add my degrees to my minutes. Awesome. That's what we're looking for. There's our double check. I know you're all on mute, so your celebrations aren't coming through, but I know you're just like up and dancing right now, right?
Yeah, it's so nice because I was kind of second guessing what I was doing beforehand. Oh, I see, Kenny, you found the you found the celebration button.
All right. Does anybody want me to go over anything else that we've done? We can rehash any part of this that you want. I'm going to say we need a little bit of a break, so we're going to take about 10 minutes. It is 7:55 now. So if we come back and regroup at 8:05, we can start tackling the next parts of the questions, which were, I don't know, something like this. All right, so we did 1, we did 2. 3 is going to start being a little tricky. We're going to have to start looking at coordinates. So you guys ready for that? It's all good. All right, 10 minutes. Send me a chat if anybody's got any questions. Otherwise, I'm just going to pause and mute and go let the dogs out. Okay. Everybody just about ready? I got 1 thumb. 2, 3. Oh, keep them up. Keep them up. We're doing a head count. Who's paying attention? Oh. Okay, you guys watching TV or something? If you're watching TV, you got to tell me if it's something good or not. All right. All right. So, actually, I want that back. The next step, the next part of the assignment is we need to figure out what the latitudes. I had this down earlier. I swear I'm really losing it. The coordinates. All right, so how we calculate the coordinates and the latitudes and departures. We're going to kind of merge both concepts here. Coordinate systems, we're all used to those: geometry, trigonometry, sine, cosine. We've been doing that as you get through calculus. You know, as you keep going with the math, coordinates are going to be your friend, right? It's going to be finding the area under a curve. Well, we have to be able to graph the curve. So we're going to be looking at a lot of coordinate systems as our careers go on, right? What we want to figure out here is if we start at point A and call that our 0, 0, that's going to be our origin. So we're going to say that's going to go right there. That's going to be our point A. To go to point B, we want to figure out what our, I don't know why I am completely blanking on this, our latitude and departure. I should be able to remember this. I want to depart to a nicer latitude. That should be my cue. All right. So bear with me. Mondays are long. All right. So what we want to figure out are the X and Y components of our coordinate system, right? What is the X and Y coordinate for point B? First thing we're going to do is sketch the line, right? So we are at 43 degrees off, or 53 degrees. We're not going to go whole numbers right now, just for the graphing portion of it. I just want to get something kind of close. What I did earlier, I did it on engineering paper. I'll show you some of those. And really, I just kind of roughed it in. So if it was less than 45 degrees, more than 45 degrees, approximately 45 degrees, that's really easy to sketch in by hand, and it gives you a rough idea of what you're dealing with. Basically, which direction are we headed in? So just like with our Cartesian coordinate system, up is positive, down is negative. To the right is positive, to the left is negative. Only instead of up and down and left and right, it's north and south and east and west. We're just giving them spatial nomenclature instead, okay? So I want to draw this line. I know that my bearing is 53 degrees, close enough. But my ruler here is being weird, and it's saying that 90 degrees is straight up. So really, in order to figure out what that angle is, I have to back out that 53 degrees, right? So 90 minus 53 is 37?
Yeah, 37.
All right. So here's going to be my 37. I'm not going to draw this to scale, really, because all we're really just looking at similar triangles kind of thing, right? So I'll start with red. I'm up here, just going to sketch in my line. Now, in order to find the coordinates of point B, which we're just randomly saying are out here in space, what do we know about this line in order to figure out what these coordinates are? We've got our two pieces of information, right?
We know it's angle and direction.
Angle and distance, yes.
Distance, right, yes. Thank you.
So we know this angle here, right? And we know the length of that line. So what does that do for us? Our drunken chant around the bonfire. Okay, we can calculate our angles. We can calculate our distances and find out what these other sides are. So latitude and departure. Latitude is the y coordinate, departure is the x coordinate. So then we talk about where we are relative to our origin, but we can also talk about where we are relative to other points in space, okay, based on the latitude and the departure. Latitude is the vertical component, departure is the horizontal component. So that's what we're going to calculate here. It's based off the bearing angle. So this would be our latitude, this would be our departure. So what we can do here is say that this is going to be our adjacent. Oops. Jeez. But it's also, it's our delta y, right? We see that this, which is the same up here as we saw from our slope example, is our opposite. What was this? Anybody remember what this length was? There it
I
is.
have 567.31.
Okay.
Hopefully that's right. Oh, wait, no,
34.
567.34.
I think somebody was just kind of going down the numbers. 5, 6, 7, back to 3 and 4. All right, so we got 567.34. And our angle was 53.49, right?
Mhm. Right.
Shrink this down a little bit because we're going to take this same coordinate system and put all of our calculations on here so I don't have to keep redrawing it. All right. So there's the data that we have for that line. What does that give us?
That'll give us the position of B, because cosine will equal x and then sine will equal, or sorry, opposite. The sine will
Okay.
be x and cosine will be y if we put that in the coordinate.
Put that SOHCAHTOA there.
Yeah.
Do another little text box. All right. So we'll call this one AB. So we have the cosine of our angle, which is 53 degrees, 49 minutes, times our distance, 567.34, equals, and then this isn't going to let me insert a delta, is it? I don't know. Let's see. No. Okay. That is going to be our departure. Anybody got that number yet?
Uh, 334.91.
What I got. Perfect. All right. Let me expand this out a little. You guys all see this well enough? If I make it too small, let me know. All right, so that's going to be our departure. So our sine gotta love copy and paste, right? So what do we get here?
$457.94.
I got 9.2. And that was a 4. Okay.
922. Or rather,
Is that what you
921
got?
also. Yeah.
Okay. So that's what we're going for here. We want to figure out those coordinates. First one's really easy. We're starting with 0, 0, and we're saying we're going out 334, 335. We're going up 458, roughly and rounding. Okay. So that gives us our coordinates for point B. This is where shit starts getting weird. All right, this is where we've got to really keep track of what direction are we headed, which way are we going, and whether or not we add it or subtract it in order to get our points in space, okay? Because technically the formula was my x component at B minus my x component at A, my y component at B minus my y component at A, gives me my coordinates. Not so much here, right? Much easier. So now that we have that information, I swear I will figure out why it's doing this someday. Today is not that day. All right. Our next line is line BC. I could use graphing paper, sketch out that line, use the right angles, give it the right distance, and basically just map it out. Might not be a bad idea. Get the hang of it for a while. My preference for this part of things is to figure out the components one by one. All right. So here's how I would approach line BC. First of all, I'm going to sketch it in. All right. What was our angle there? We had 51.26. Right? South, 51.26 east. So I need to come back this way. So I need to take that difference between my 90 degrees here. That's just, and then I had 51. So I'm roughly 39 degrees, right? Is that right? So roughly, there's my BC. So what I'm gonna do is I'm gonna put my little tag down here, and my distance was 810.76. And my bearing was 51 degrees and 26 minutes. Okay. With me?
Yeah, I'm with you.
Okay, that's one. All right, we know that this angle is our 51.26. Same exact process. So the nice thing is I'm going to copy this over and simply adjust the details. All right, what are my details here? This is line BC. It's the cosine of 51/26. And my length is 810.76. And that's going to be my departure. And because it's easy to do this, I'm going to copy and paste. Down below. All right. Everybody got numbers? So I have 26 minutes. I divide that by 60. I add my 51 back in. I take the cosine of that. I multiply by 810 and 76 and get 505.45. Nice. All right. Same process again. 51. Sine of the angle this time. Nice. 633.92. All right. So these were our coordinates at B. 334.94, 457.92. What we just found, our departure and our latitude, are magnitudes of values. They're not the actual coordinates. Now we have to convert them to something we can use. Okay? This is important information. We're really killing two birds with one stone on this. So please ask questions. We'll back up. We'll cover anything else we need to. Okay? But here what we're going to do is we have the net difference, our delta y, our delta x. That's really all we got. If I were to take this line here and paste it up here, that's really what we're looking at. So by that reasoning, from our coordinates here at 334 and 457 to down here, we are decreasing because we're going south, right? So our latitude is a negative number. Our departure, we're still going to the east, so we're adding to our number. Okay? Does that help, hurt? Okay, that's why I like sketching this out, because you can see, where am I supposed to be? What's my gut check? Okay, awesome. All right, so now we can see kind of where we should be, whether we add or subtract to our coordinates at B. So our coordinates at C are our x coordinate at B, x in lower B, right? So our x at B, we're going further to the east. So I'm going to add my departure, which is 5, which is my D, right? And then my second point is my y coordinate at B, but because I'm going down, I'm headed south, I'm going to subtract my latitude at B. Okay. That's going to give us Our x coordinate at B is 334.94 plus 505.45. Our y component is going to be 457.92 minus 633.92. And that's going to equal put a space here. Okay. What was that? Did anybody get something totally different? Even a little different?
I don't think it's 8:30, is it? I think
Yes.
it's 8:40.39.
Oh, we're talking about the time.
Oh, yeah. No, I'm talking about the problem. I don't think it's 8:30.39. I think it's 8:40.39. At least
It
that's what I
is.
got.
You're right. I'm sorry.
Yeah, don't worry about it.
All right. So we'll keep going. All right. We found BC. So that's good. That helps. I'm going to expand this out just a little bit more. Because now we're looking at C to D. I'm going to get my ruler out again. We'll use the green pen this time. I need to use a smaller point on it. All right. So what was our bearing from C to D? Well, thank goodness we had our table. From C to D, south 41 degrees, 38 minutes west. All right, so let's say it was 41 degrees off our vertical to the southwest. So we're going negative and negative on both of those. So what's my 90 minus 41? 49. All right, just rough. Oops. I guess that's all we're going to get for that line. All right. So our angle, our 41 degrees is right here. Our details, we'll map those out and put them here. Let me resize this again. All right, so our distance was 922.75, and our bearing was 41.38, right? Just going to take that whole thing and copy it over and doctor it over here. Except this time we're looking at C to D. Our angle is 41 degrees, 38 minutes. 922.75, which means our departure is not soon enough. Nobody can go anywhere. Not allowed to have any fun. No travel, no vacations. See, even my dog's growling in the background. She's mad about it.
Yeah, same here.
All right. What? All right. I have to step away for a minute. My 12-pound little alarm clock is mad at me. So what I'd like you guys to do is go ahead and finish this off. Let's see what we come up with. I'll come back and finish these numbers. This was 41. Stop it, Lucy. She's 12 pounds. She thinks she runs the show around here. All right. So we want to know what the latitude is. We need our coordinates for C. We need our coordinates for D. Except we're going to subtract both of those values this time. All right. I'll be back in just a minute. I got to figure out why she's mad. She wanted a drink of water, but the other dog was in the way.
Oh, that's funny.
All right. Did anybody get the latitude yet? Oh, I'm not even there yet, man. Okay, let me see if I can catch up to you. 613.04 is my latitude. So my coordinates from C oops, come on. These numbers, right? Right. So my
Right.
coordinate from C, my x coordinate minus my departure. So I have 840.39 minus 689.67. And 613, oops, negative 176.00 minus 613.04. Yep, 150.72. I got that. And then I have 176 negative and 613.04 also negative. 789.04. Excellent. Okay. So just like last time, I'm going to rough this in. Of course, that is not to scale. So let's see. That's not going to let me do anything with it. That's not what I wanted. Come on. There we go. So does it make sense that we are below our line, our horizontal axis, by 789 feet? And that our X coordinate is 150. So these are not to scale. That's the only problem that I've done here. Okay, I probably should have done the lengths to a better scale, make them something a little bit more manageable, because this line should be 922 feet, whereas my A line should only be 567 feet. So it should be much shorter. So really what we end up doing is, if we were more to scale, probably be a little more like that, right?
Mm-hmm.
If I can get this line to move. So we're at 150, but our negative point is almost minus 800. So we'd have to play with it a little bit just to get the diagram completely correct. But really what we're going for is a rough schematic. Does it make sense that we've gone down and back, okay, based on the lines that we've got drawn in? We've got 2 more lines to do. So let's go through and get those done. And I can show you the spreadsheet. It's just like we did with the leveling, okay, in terms of errors of closure and precision. So let's do the next couple. Handy dandy ruler. Love the little compass thingy. All right, our line from D to E. Come on, Lou. Come on. Big dog in the way again. All right. All right, so if I start out at my vertical here, I'm north 41 degrees, 10 minutes to the west, okay? So my Y component is gonna be additive. My X component is gonna be subtractive. Lou. All right, so roughly 49 degrees. Do my line here. What was the length of this line? 411. Try and get a little closer. All right. It's so pretty. All right, let's take this and put our information over by our yellow line. Our distance was 411.72, and our angle was 41 degrees, 10 minutes. Rinse and repeat. that. So this one is from D to E. This one's a little easier to manipulate. All right, 411.72. I'm going to start abbreviating this because these are getting kind of large. All right. Okay. Was that your departure and latitude, or is that the new coordinates? How far did you get?
That's just the departure. I'm doing
Okay.
the other part now. I just looked at where your cursor was flashing. And I was like, okay.
Yes. All right, but you've got two numbers there.
That's the departure and latitude.
Oh, and latitude. Okay. I'm gonna do something right, I think. Oh, yeah, it helps if you actually take the cosine of the angle. Yep. Okay. So, Mason, what we can do for now is just figure out the magnitude of the latitude and departure, and then we'll figure out what we need to do to assign it down below. Okay. So for now, I just want to get 41, take the sign. 271.02. Awesome. All right. So remember, this one is north. So my latitude is additive. My departure is subtractive. So here I'm going to have my 150.72, which is my x coordinate at point D. My x coordinate is going backwards, so I'm going to subtract 309.94. The other part of my component is minus 789.04, but it will be plus 271.02 because I'm going up. Okay.
But wouldn't it be plus plus since you're going up and to the left?
No, left is negative.
Oh,
West is backwards, right? It's towards the negative side.
I see. Okay.
Sorry, now the other dog is mad because the big dog is in the way. All right. So 159, is that what we're getting? Okay, nice. Consensus?
Yep, you got that too.
All right. Oh, thank you. I don't want to have to do that math. All right. So there's our point E. Now, let's make sure that we end up back at our starting point. So we can do this one last time from E to A. All right, so our E to A was also a northwest bearing, but this was only 20 degrees off, right? So I got my ruler. That puts us at about 70. Need a new color pen. We're going to use pink. Use glitter. Yeah. All right. All right, and that's this angle here. So we just keep going around and just document what we're doing, right? So we got 588.16, 20 degrees, 41 minutes, off to the northwest. So we're going to add the vertical component and subtract the horizontal component. Oops. All right. So this one's going to be from E to A. 20 degrees, 41, 588.16. Did I just, okay. Anybody want to guess what we're supposed to get? Hopefully, fingers crossed. All right, so let's take the cosine of this angle. Departure, I got 550.25. If you guys get anything different, please let me know. I'm notorious for transposing digits. So I haven't even done the math yet, and I've got kind of a sinking feeling here.
Same
All
here.
right. Subtract my departure. Oh, crap. My latitude. Something did not go right here.
Excuse me, can I have a suggestion?
Yes, please.
Okay, I got confused somewhere along the line, and I didn't want to interrupt because I thought it was me just being confused. But I think we mixed the sine and cosine thingies in the calculation, because it's cosine times hypotenuse that is supposed to give us y coordinate, not x, according to this picture. Sorry. Does it make any sense? It's sine of the angle times hypotenuse gives us x, and cosine
so
times
good, that's all.
hypotenuse gives us y, according to this picture of these angles.
Okay.
Is that,
Here's,
I don't know. Do you see what I mean, or am I wrong? I don't know.
yeah. No, no, you're,
Okay, I'm sorry. I thought it was me being confused, so that's why I stayed quiet. I'm sorry. Happened to me before, sorry.
okay. So here's a way we can check that. All right, so basically we've just got our names reversed on most of these, okay?
Yeah.
But what happens is when we start adding or subtracting, that's when it throws us off. Othello, are you snoring or is that a dog?
Oh, that's a dog. So sorry. That's my bulldog.
Oh,
Sometimes I don't realize how loud he is. All right, you're awake. Thank you. Oh my goodness.
I was just starting to get worried about you. All right.
Yeah, I appreciate it. Thank you.
So from A to B, let's put this into the formula and let's see what we get. See if we can figure out if we reverse it. I'll go through, I'll fix the coordinates because that's what threw us off. We'll flop our latitude and our departure. So this table is showing us that if it's a north, we add it. If it's a south, we subtract it. Okay. All right. So our first one, our latitude, which is actually our departure. Okay, so that's our x coordinate. That's east-west. AB was a northeast bearing. So we have 457.92 towards the east. Okay. Our north value is going to be 334.94. Okay. So if we come down to the next one, again, we're backwards. So our latitude, this is our departure, not our latitude, 633.92. But what's our line doing? It's still going to the east. So our departure, which is our x coordinate, which is going to the east, is going to be positive. So we're going to put that here. Okay. My bad.
Oops.
Right? All right. Thank you. All right. So taking our next one. Oops. With our backwards latitudes and departures. Oh, that was, okay, that was not it. All right. So if we're backwards, this is our green line. So we have a southwest system. What number do I put where?
The one with cosine for the vertical and the one with the sine for the horizontal. That's as far as I can keep up with it. Sorry.
Okay, wait, say that again.
The one with the cosine for the vertical and the one with the sine for the horizontal coordinate.
Okay. Vertical is north-south.
No.
So since we're
Wait,
going
wait,
south, we want to put this in the 689.67. Okay. And it's a western, western.
Yeah, so it's also negative, yeah.
Okay, 613.04. All right. Jeez. All right, DE. Our departure, we're backwards. So this DE is northwest, so north, 309.94, 271.02. Another northwest, using our latitudes and our departures again, get my spreadsheet back, still north, and this is going to be 550.25, and this is 207.73 because it's off to the west. Okay. So,
Looks about
yeah. Question?
The last one, I'm kind of not getting. Shouldn't 207 be positive because it's going from left to right? No?
No, it's still going to be negative because we're going west with it. It's going north, so the vertical component is positive, but it's going west, so it's going to be negative.
Okay.
Okay. So I didn't put the signs here. The signs are up in my header row just for explanation. But if I change my font color, because I already ran some formulas here, oh man, I deleted them. Bummer. All right. So if I add up this column, just like we did with the leveling, right? If all of our norths are counteracted by all of our souths, and all of our easts are offset by all of our wests, we're good to go. That's pretty close. Olga, you saved us. Okay, me. All right. So one of the last steps that we were going to do, all I did was add up all of my norths, all of my souths. Now I want to take the difference between the two. So I'm going to say take my north, subtract my south. What do I get? 0.01. Well, this is Excel, so I can run that out a little bit. That's really not much. That's a pretty small number. I can do the same thing. Take all of my easts and subtract all of my wests. 0.05. Now, are we within acceptable parameters? How do we figure that out? Our error of closure, our formula for that. So I'm going to minimize the wrong thing, of course. All right, our error of closure is the error of our latitudes squared plus the error of our departures squared, and then the square root of that. Kind of tells me there's some Pythagorean theorem going on here, right? Oh, Pythagoras.
Yeah, it shows up everywhere.
There's a reason we force him down everybody's gullet.
Right.
There was no way I was coming out of that one. All right. So if I take those numbers, 0.05, figure out which button I have to push on my calculator, and my 0.01 and square that, I add those two together, I take the square root of that, I get my error closure, 0.05099. All right, but is that acceptable? So the way to figure that out is to figure out all those different lengths that we went, what's the average? What's the proportion, right? So we are off by 5/100ths for how far? Our total perimeter, right? 3,300. So we would have 0.051 for 3,300.73. Oops, 0.73. But our precision is usually reported as 1 for every so many feet, right? So I'd take my 3,300.73 and I would divide that. All right. I don't want to throw the number out there. Somebody else do it. Anybody else? So we are off by 1 foot for every 64,733 feet that we traverse. Not bad. All right. It's 9:05. The bulldog says it's time for a nap.
Yeah.
We did not get through everything that I wanted to cover tonight. So I need to figure out a way to get you the rest of the information on how to, what were the remainder of our questions that we didn't answer. All right. We figured the bearings. We got the interior angle at A. Coordinates, not so much. I'll go through and I'll fix those so that you guys have an example, okay? The math will be correct. I'll post that whiteboard screenshot into Canvas. We didn't compute the area of the traverse. That is available in the book. It does explain how to do that. And really, it's just make a lot of triangles, all right? Generally what we're going for with that whole concept there. So the area and the coordinates. Those were two items that we, A, didn't get to, and B, I kind of screwed up. So I will fix.
Oh,
Yeah,
sorry.
Othello?
And 5
Go ahead.
is related to 3 as well.
Yes. Yeah, it is.
Right.
So we were able to fix it to get a result. The problem was now we didn't get 3 done correctly. So I'll fix 3 so that you guys have an example. But basically, these 5 questions are your homework. It's a different traverse, but you've got missing information. We just need to make sure that we get it caught up. Okay? Get everything finished up. So at this point, yeah, we're safe going to lunch. We'd be able to go to lunch and then finish it up when we come back. But this is why multiple heads are better than one. speak up. Stop me before I make a total mess of things next time. Tell you what, I would, here's what I'd like to suggest. The exam was not hugely successful for everybody. I'd like to offer 5 extra points added to your exam if you go through on your own and submit 3 and 4 on this example. What do you think?
Will it have to be on engineering paper? Well, yeah, basically. I was I was gonna do it on my whiteboard just in case I made a mistake and had to erase everything a little easier.
You know, I'd be willing to accept.
Okay.
Yeah.
All right.
No, not from the exam, Luis, not from the exam. Do these 2, 3 and 4, these 3 and 4. They're bonus points. Okay. So I know some instructors, and Marcina has mentioned this before, they give you an opportunity to redo the exam after the fact for partial credit on a problem. The cat's out of the bag on that one. I mean, it's been out there for too long. I don't think that is going to help with the situation, especially with the conversation we had to have coming into class today. Fairness, preparation, integrity. We're just going to take exam 1. We're going to move forward. We still need to know the material. So absolutely, let's go over it. Set aside some time. I'll take an hour, sit with you. We'll use the whiteboard. We'll go through each question. If that's what you want to do. Okay. If you want to do it one-on-one, I'm totally game for that. My goal is your success. So that's what I hope to get out of this class. Take this traverse, rework 3, submit 4. What's a fair deadline for that? By Wednesday office hours? By Thursday at 5 p.m.? What do you guys think?
I think
I've got
Wednesday.
work every day, so the longer the better.
Okay.
Okay. Yeah. I agree with you, Kenny. If it works for you, I'm open for any day. So,
Let's see. You guys do have a lab coming up this weekend, right? So there is the homework, which is really just this. So we're giving you more practice. The extra credit is these 2 questions. Those will be due, let's say Friday at 5. I'll grade them with a glass of wine. It'll be great. Okay. I'll get this posted to Canvas, lay out all of our conversation for this, post this screenshot again, so that you have it. Okay. We said 5 points. Let me write that down because I would have given you 10. All right. Good? Okay. Does anybody have any questions, anything they want me to go over again? And don't say redo number 3.
Just a quick question. On the homework, do we have to remain in black ink or can we use multiple colors of ink for clarification?
I'm okay with multiple colors. My dogs are gonna go nuts. Somebody just pulled in. Here's what I tell, and I say my guys, here's what I tell my estimators when I'm doing trainings with them, because we can color code things in our software. So sorry. Oh, bless their hearts. All right, so if it looks like a unicorn crapped on your paper, no, I don't want multiple colors. If it is organized, thoughtful, and used sparingly, fine. I'm okay with that. Yeah, I always use pencil anyway. So ink is just way too permanent. I'm a paperclip person. So if that helps, go for it. Is engineering paper feasible for everybody? Are we good with engineering paper going forward on the homework? All right.
I'm sorry, is graph paper kind of engineering paper, or am I doing it wrong?
Technically, it's not, and they
Oh.
other professors will differentiate, and they want engineering paper. And going forward in other classes, I would say be prepared. Tell you what, I'll take graph paper. Don't tell Joanne. But yeah, graph paper or engineering paper is fine. Okay.
Thank you.
My dogs are gonna go nuts again. There's somebody driving around my property. I have no idea why. All right. So 5 points, Friday at 5, 3 and 4 from our sample traverse. The homework is posted to Canvas. I still haven't graded homework number 3. I will get 3 and 4 graded as soon as humanly possible. More than likely, we will have a quiz next time. Let's see, what do we have? Homework, assignment 3, reading chapters 11 through 13. We'll circle back to chapter 10 and pick up those parts and pieces. Email, Canvas. If you want some one-on-one time, you want to go over any of this, just let me know. Okay, more than happy to sit with you guys. My boss is on vacation for the week, so my day job is kind of cruising. Any questions before we go?
All right. And so chapter 11 to 13 just covered this lecture and then some.
Yep.
As well. Yeah.
Yeah.
All right.
I'm sorry. It just makes me laugh.
Yeah, I know. It's so
that
hard
is-
to concentrate. What happens is, so I put him on the bed, right? And so now how he sleeps is, for some reason, he loves pillows. And that's the only reason he'll fall asleep. So he has a pillow in his mouth right now. And so his snoring gets louder every time he has that in his mouth.
Is it an English bulldog?
Yes, he is. I believe he's
Oh,
a purebred. So
Oh gosh. Okay. Well, if you guys don't need me, go for it. Go forth, be safe. Stay out of trouble.
yeah, I appreciate the help. Thank you.
You guys are very welcome. Jonathan, are you still on?
Yeah, I'm still here.
Okay. Did you want to go through and look at what assignments I have from you?
No, that's all right.
Are you sure? I mean, this is the time. This is a chance.
No, I'm just having a hard time with this stuff right here, so I've been trying to go over it, but I'm not really getting it.
Okay, which part?
I didn't really get any of the last homework. I
Uh,
was trying to figure it out. I was trying to read the book. I wasn't getting it at all.
so the angles, right? So
Yeah,
that was
yeah,
the intro to bearings and azimuths. Okay.
exactly.
Um,
Then I feel like I'm just trying to keep up doing notes, so then I kind of lose it, you know?
no, I get it, but and that's the I know what I'm trying to say. The PowerPoint presentations, those do get posted. So
Yeah,
those are available. The recordings, those are available as well for refreshers, things that we talked about as we work through the prompts. I don't know if that
yeah.
would help. I was late getting this one posted. So do you,
I
are
was just
you
super.
available?
I was just super busy last week too, so I did class, but I didn't really get a chance to go over the class again.
No problem.
And so I've been like kind of sitting here going over the homework as we're doing this new stuff.
The new stuff is really just a continuation of the homework. That's
Yeah, that's. I
really,
mean, I need to.
are you available on Wednesday? Can you come to office hours?
Yeah, I can.
Okay, let's
Um,
go over it then.
okay, Wednesday. Wednesday. What's your office hours? I forget.
12:30
12:30,
to
2:30.
2:30. Yep.
All right, I'll hit you up then.
I mean, does that work? Do you need a different
Yeah,
time?
that's fine. Well,
Okay,
even no, that's fine. Just even after today, I'm gonna go back and check out the homework and see what I can pull together.
okay. And I'll get the homework solutions posted as well. Turns out I did something
Okay.
way wrong when I was doing the homework, so I need to go back and redo some of the problems. So, oops.
All right. I'll check it out. Thank you.
You're very welcome, Jonathan.
All right, bye.
See you Wednesday.
Okay.
How you doing, Marcine?
I'm doing good. Just been working out on my other classes. How are you?
Same. I was thinking to myself just this morning, gosh, it'd be nice. I just need to take a day off, you know, take a mental health day, a sick day at work. And then I thought about, well, no, because then all the stuff that I have to get done around home and for school, and I just end up doing all that. I wouldn't actually get a day off. So might as well just keep chugging along.
Yeah, it's hard to find a good time.
Yeah, never easy.
Mm-mm.
What classes are you taking?